Hello dear students. So today's we will make a video on the chapter the D and F block elements. The chapter D and F block elements from the inorganic part seems to be most important and is considered to be a backbone for inorganic chemistry of class 12th. So before I get started with the actual part of D block elements and F block elements, I must have to tell you regarding the blocks of periodic table. As you have already done in class 11th regarding the periodic classification of the elements and their properties as well as S and P block, you have studied there. Here we will have a glance of all those things what you have already covered and we'll move to the actual part of the chapter. So I must have to tell you regarding the periodic table. I have put here a feasible periodic table, and in that we have seen the S block is stipulated at the extremely left of periodic table. Extreme left of the side we will be finding S block elements. Likewise, you can see here at the extreme right side of the periodic table you will be getting a P block elements. P block elements will be starting from the group 13 to 18. And the S block elements, they will be start from first group, second group. Both the groups are said to be S block elements. And at the center of the part of the periodic table from group 3 to group 12, all are said to be D block elements. I repeat, from group 3 to 12, all are said to be D block elements. Now, there are mainly of 4 series are present in the D block elements. Say for example, this is said to be 3D series. This is said to be 4D series. This is said to be 5D series and it is said to be 6D series. So each series comprises 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9 and lastly 10. So there are 10 elements in each D series. The first series which begins from scandium is said to be 3D series. And the second one which starts from yttrium is said to be 4D series. And the next series actually starts from lanthanum, that is we have lanthanides. But the thing is we have these 14 elements will be having the property similar to ಅಂದ್ರೆ ಇದು F block elements ಒಳಗೆ ಏನು lie ಆಗ್ಲಿಕತ್ತದಲ್ಲ, if you fix that one here and if you go on writing first of these, then if you are writing all these next to that one, this will go away from the periodic table. It will be coming very away from the periodic table. So in order to make the things systematic arrangement is done just by considering atomic number 57, that is lanthanum. From lanthanum, all the 14 elements are said to be F block elements, right? And the series which starts from hafnium is said to be 5D series of D block elements. Likewise, we have rutherodium, that is said to be 104. Before to that one, I have actinium. And from actinium, all the 14 elements which are present, all are said to be actinides. Generally, all the F block elements are said to be radioactive. Don't worry about that one. First, let us begin with D block elements. We'll have a clear idea regarding that one and their properties. How does the changes, variations will be taking place with respect to electrons. Everything will complete. Then we will move to the F block elements. Right? So, one more thing I would like to tell you here, that the most important part of D block elements is said to be 3D series. You need to remember these 3D series elements along with the electronic configuration and atomic number. Once we come to know that, once we memorize the atomic number, definitely it is very easy to write the electronic configuration for any element from the periodic table. Okay, because we have studied atomic structure in the previous, that is first year, PUC first year, we have studied atomic structure. There we have followed a Fou's principle, Hund's rule, right? All those have given us clear-cut idea regarding how exactly electrons should be arranged in the electronic configuration. And the same knowledge what we have gathered will be using here for the D and F block elements study. Fine. So it is going to be start from here. The first element from the 3D series is said to be scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and lastly we have zinc. Coming to the next series of 3D series, at least it is fixed. All the elements of the 3D series you have to remember, right? Then from the 4D series, you need to remember regarding palladium, silver, cadmium. These three are said to be most important. Likewise, zirconium. Then we have platinum, gold, and mercury. So these are most probably, in the sense, most frequently used elements for transitions. So now these D block elements are said to be transition elements. What they are called? They are called as transition elements. Why does this name of transition elements has given for the D block elements? Is mainly because the properties of S block elements are going to be carried with the help of D block elements up to P block elements. Certain properties of S block elements also shown by P block elements. These are considered to be carriers of properties of S block towards the P block elements. The reason why these D block elements are said to be transition elements. Such question can be asked for 1 marks in your examination. Okay. Then we have 3D series, 4D series, 5D series and 6D series. So we need to understand all these pink colored representation of elements which are considered as D block elements. Fine. So let me give you some more idea regarding F block elements also. So F block elements, they will be start from lanthanum and they will be ending with a lutetium. They will start from atomic number 57 and they will be ending by 71. All the 14 elements are said to be lanthanides. And we have next 89. See here, once we complete 71 lutetium, 57 to 71, that is 57 to 71, all these are said to be actinides. Once we complete 71, we have got to know regarding 72, hafnium. From 72 to 86, radon, from hafnium 72 to Hg, mercury. These all are said to be 5D series elements, D block elements. Then you consider, once we complete here 80, we are going to start with next one. Once we complete here 80, next will be lying in a P block elements, and the 6D series starts from 89. But the thing is, 89th element is said to be actinide. So actinide belongs to F block elements from 89 to atomic number 103 lawrencium. All are said to be actinides. The first F series is called as actinides. Lanthanides. The second F series is said to be actinides. Lanthanides, actinides, both the periods belongs to F block elements. Then we have from 104, atomic number 104 to 112, all are said to be 6D series. So this 6D series is incompletely filled. Still inventions have been going on this period. So we don't bother about this one at all. We generally bother with these two mostly, and some of the elements of 5D series also. So I have shown this periodic table just to brush up your knowledge what you have already studied regarding the periodic table. I repeat once again all the things for the periodic table. That is, the first two groups are said to be S block elements. Group 1 elements, all are said to be alkali metals. Group 2, all are said to be alkaline earth metals, right? In between, what we have from 3 to 12, all are said to be transition elements. They are called as D block elements. Then we move to P block elements. I told you P block elements are starting from group 13 to 18. And these P block elements as well as S block elements are considered as representative elements of the periodic table. See, then we have F block elements, right? And I explained you how does F block elements will be starting from here, and they have arranged in a separate rows of periodic table at the bottom of the periodic table. And remember, almost all the D block elements will be showing a kind of metallic property. Transition of properties from, yes, we all know S block elements are metals, alkali metals and alkaline earth metals. Even we found some of the metals in P block elements also. We find metals, metalloids, non-metals in the P block, and the property of this S block is going to be carried by the transition elements towards the P block elements. So the reason why D block elements are called as transition elements. So this is all about the periodic table including D and F block elements. Now coming to the actual part of the D and F block elements, we need to understand regarding how they shows arrangement of electrons. We are supposed to write the electronic configuration for D and F block elements. Let's do that one. Now let us discuss regarding the electronic configuration for D block elements. When you consider electronic configuration point, we need to remember the last electron is going to be enter into n-1 D subshell. The reason why they are called as D block elements. We have seen S block elements in which the last electron will be enter into S subshell or S orbital. They are called as S block elements. Likewise, we have seen P orbitals also. Last electron will be entering into the P subshell or P orbital. So the reason why they were called as P block elements. Now the thing is, with respect to D block elements, if you consider, the last electron will be entering into n-1 D subshell, and the reason why they all are considered as D block elements. So if you consider the general electronic configuration for D block elements, we supposed to write the filling of n-1 D 1 to 10 electrons. The capacity of D block D orbital, it is 10. We have seen this orbital structure, that is electron cloud structure, everything we have seen in detail in the chapter atomic structure in class 11. So D block elements, if you consider, they have a capacity of 1, 2, 3, 4, 5. So they have capacity of 10 orbitals. They can accommodate 10 maximum electrons in it. So now I have written here, I would have written NS filled first because S orbitals will be coming first. Then the D orbitals would have filled. But due to very less energy gap, I have shown n-1 D 1 to 10 electrons filling. Later I have shown NS 1 to 2 electrons filling. With the help of example, as I have told, with the help of example, I will explain the things here. Before to that one, remember, we have 5 orbitals. We will be filling the electrons in this fashion. 1, 2, 3, 4 and 5. If 10 electrons are completely possible, then we would write like this. So this is how we will be filling the electrons in the D orbitals. Now see here, why I have shown n-1 D 1 to 10 and ns 1 to 2. Just listen to me. I have a nucleus of an atom which is positively charged. Then I have certain shells present over, subshells present over. Fine. Let us consider this one as ns orbital. Okay. And very inner side itself we will find n-1 d subshell. n-1 d subshell is present inner side of the s orbital. I am mentioning this thing here is mainly because the energy gap between these two. I write here the energy gap between n-1 d and ns is very less. So once the energy is very less here, the electrons can transit from s orbital to d and from d to s. ಕನ್ನಡದಾಗ ಹೇಳ್ತೀನಿ, ಕರೆಕ್ಟ್ ಆಗಿ ಫೋಕಸ್ ಮಾಡಿ ಅರ್ಥ ಮಾಡ್ಕೋರಿ. ಓಕೆ, n-1 d orbital is inner orbital. Okay, s orbital is considered to be outer orbital. ಎನ್ ಡಿ ಆರ್ಬಿಟಲ್ ಇಂದ ಎಸ್ ಆರ್ಬಿಟಲ್ ಇಂದ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಎಷ್ಟು ಕಡಿಮೆ ಐತಂದ್ರೆ ಬಹಳಷ್ಟು ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಏನಾಗ್ತದೆ, ಎಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ವಿ ಹ್ಯಾವ್ 2 electrons, ಕ್ಯಾನ್ ಕಮ್ ಅಂಡ್ ಜಂಪ್ ಟು ದ ಡಿ ಆರ್ಬಿಟಲ್. ಸಿಮಿಲರ್ಲಿ ಡಿ ಆರ್ಬಿಟಲ್ ಇರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ದೇ ಕ್ಯಾನ್ ಜಂಪ್ ಟು ದ ಎಸ್ ಆರ್ಬಿಟಲ್ ಆಲ್ಸೋ, ದಟ್ ಈಸ್ ಪಾಸಿಬಲ್. So this is the condition why, I repeat my words, such condition is going to help us regarding the involvement of electrons, s orbital ಒಳಗಿರುವಂತ electrons as well d orbital ಒಳಗಿರುವಂತ electrons ಎರಡೂ ಕೂಡ ಬಾಂಡಿಂಗ್ ಒಳಗ ರಿಯಾಕ್ಷನ್ ಒಳಗ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡ್ತಾವು. The s orbitals and the d orbitals electrons will be taking part in a bonding or in any valence electrons ಅನ್ನ ಜನರಲ್ ನಾವ್ ಏನ್ ಮಾಡ್ತೀವಿ, ಯೂಸ್ ಮಾಡ್ಕೋತೀವಿ. ಬೇರೆ ಕಡೆ ನೆನ್ಪು ಮಾಡ್ಕೋರಿ, s orbital ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರ, p ಬ್ಲಾಕ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಆಕ್ಚುಲಿ ಏನು ಯೂಸ್ ಮಾಡ್ಕೋತಿದ್ವಿ ನಾವು, ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ. Okay, valence electrons are those electrons which are loosely bound, they are away from the nucleus. But here in this case, for d block elements exclusively, if you talk, we will be making use of s orbital as well as d orbitals will be participating. I write here, this is the first and foremost point we have to remember. Along with that, I must write here in let me write the d and s orbitals, that is, let me write n minus 1d, n minus 1d and n s orbitals will be ns electrons, sorry, electrons will be participating in bonding. Okay, so these are most important and 2 points we have to remember. Once we understand these 2 points, it's very easy to understand the chapter d and f block elements. Fine. So we have a nucleus, we have n minus 1d orbital, we have s orbital. The energy gap between these two is very less, it is very small. So transition of this electron, the movement, jumping of the electron from s to d and d to s will be always taking place. ಆಗ್ತಿರ್ತದೆ ಯಾವಾಗಲೂ ಅಲ್ಲೇ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗ್ತಿರ್ತಾವು, ಶಿಫ್ಟ್ ಆಗ್ತಿರ್ತಾವು, ಜಂಪ್ ಆಗ್ತಿರ್ತಾವು. So that is the first point we have to remember. Energy gap is very less, so electrons will be taking participation. ಜನರಲಿ ಔಟರ್ ಶೆಲ್ ಒಳಗಿರುವ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ವಿ ಬಾಂಡಿಂಗ್ ಪರ್ಪಸ್ಗೆ. ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಜಾಸ್ತಿ ಇದ್ದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಎನರ್ಜಿ ಕೊಡೋದ್ರಿಂದ ಇದ್ರೊಳಗಿರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ ಕೂಡ ಜಂಪ್ ಆಗಿ ದೇ ವಿಲ್ ಆಲ್ಸೋ ಕಮ್ ಫಾರ್ ಪಾರ್ಟಿಸಿಪೇಷನ್ ಆಫ್ ಬಾಂಡಿಂಗ್. ಫೈನ್. So this is the speciality we can consider for d and f block elements. Now moving to the next part, we have 3d series, okay, we have 4d series, 5d series and 6d series. If you consider general electronic configuration for 3d series, 3d series is going to start by atomic number from 21. We have 18, atomic number 18. Once we fill the 18, we will be coming to the s block. 19, 20, there comes, then comes 21. Atomic number 21 is scandium. So 3d series starts from scandium. So for that reason, we will be making use of argon. Argon with the atomic number 18, we will be filling 3d series by 1 to 10 electron and ns1 to 2 electron. And this is said to be general electronic configuration for 3d series only. Then comes 4d series, 5d series, 6d series. We have to make use of noble gas configuration and directly we will be writing the 4d. If it is 3d, we will be making use of 3d 1 to 10. If it is 4d, 4d 1 to 10, 5d 1 to 10, 6d 1 to 10. Like that, we will be writing the electronic configuration for d block elements. If it is understood to you clearly, please do copy this. We'll move to the next point. Okay, dear students, now let us write regarding electronic configuration for 3D series. As I already discussed this point with you that the 3D series is most important and maximum time the 3D series elements are most probably asked in the examination. So let me write the electronic configuration for that. So see here, electronic configuration for 3D series. So as we all know, 3D series is going to be start from the scandium. So let me first write the elements of 3D series. Fine. So it starts from scandium. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So these are the 3D series elements. I hope below it is clear, visible for you. I'll just check it. Yes, it is visible. So now you can see here. So atomic number, if you consider atomic number, names of the elements I have written, it starts from atomic number 21. Titanium 22, vanadium 23, chromium 24, manganese 25, cobalt 26, 21, 22, 23, 24, 25, 26. This is 27, cobalt, nickel 28, copper 29, zinc 30. Fine. So now how to write the electronic configuration here. So for scandium, if you consider, as it starts from 3D series, we have previous noble gas, it is argon. It is argon, that is 18. So 18 electrons are filled. Now how many are left here? 21 minus 18, we have left with how many electrons? We left with 18, 19, 20, 21. We left with 3 electrons. Now we supposed to arrange those 3 electrons. As it starts from 3D, 3D1, 4s2 we will be considering. This inertial is, it will be inertial, but the thing is energy is less for the s orbital. We will be filling this one according to Aufputz principle. Later we will be filling the d orbital. Then we have 22. So again argon, 3D2, 4s2. Fine. Then see this one vanadium, it is argon, 3D3, 4s3. Then we have chromium. It is 3D 1, 2, 3D3, 4s2. Fine. 3D3, 4s2. Then see here we have atomic number chromium. It is said to be an exception because of half-filled electrons. It must have come 3D4, 4s2. 3D4, 4s2 ಬರಬೇಕಾಗಿತ್ತು. But it will be forming 3D5, 4s1. It will be forming 3D5, 4s1 because as I told you, the energy gap is very less. See 1, 2, 3, 4, 5. Okay, this is s orbital, right? So 3D, how many it would have come? 3D4. 1, 2, 3, 4. It would have come, and here it is 2. 2 electrons in S and 4 electrons in D. It must have come like this. But the thing is, as I told you, energy gap is very less between D and S. The electron jumps from S to D. And such configuration of partially filled electrons, partially, or I can say very accurate word, that is half filled electrons of d orbital will be most stable. That is the reason why it will occupy 3d5-4s1 to become most stable. And the provision is also there. The s electrons can jump very easily to the d orbitals due to very less energy gap between d and s. Next, the thing or the this Arrangement of these electrons will be follows as usual, that is argon, right? 3d5 4s2 it will become. Now see, argon 3d6 4s2, then cobalt, argon it is 3d7 4s2. Now we have nickel, see here, argon 3d8 4s2. Now next one I'll write here. If it is not visible also, you can see here with a clear explanation. I'll be considering next one, that is copper. So copper is 29, right? So how much it would have been? 3d9 4s2. It would have been 3d9 4s2. But it won't be like this. See, I'll explain this one. I have d orbital, 1 2 3 4 5. Then I have s orbital. It would be 1 2 3 4 5 6 7 8 9. Then I have 2 electrons in the s orbital. This is s, this is d. It must be like this. But as energy gap is very less, this p orbital, s orbital electron will come and jump here. Now it is becoming completely filled. Completely filled configuration. So exactly half filled and completely filled configuration of this copper is considered to be most stable. Half filled with respect to chromium, completely filled with respect to copper are said to be most stable. So the reason why configuration is going to change to 4d10 4s1. I'm sorry, it is 3d10. 3d10 4s1. And the next one, that is last, atomic number 30, zinc. It follows the as usual chronological order. 30, it is zinc. It will be 3d10 4s2. So now you can see here, this is considered to be a completely filled configuration. So this completely filled configuration doesn't show any transition of electrons. Any transition of electrons is not there in a d orbital, then such compounds are not said to be the d block elements. Yet this zinc is present in the d block elements. It doesn't considered as d block element due to completely filled orbital in its ground state as well as its normal oxidation state. Ground state in the sense, the exact zinc what I have written in this case we can consider. If at all excited state or any oxidation state also, if you want to pull electrons, only these electrons will be pulled off. So I would write here, just record, I repeat my words, 1 2 3 4 5. This is yes, right? 1 2 3 4 5 6 7 8 9 10. This is 1 2, right? What I mean to say is this zinc doesn't consider, it is not considered as d block element because in its ground state also it shows fully filled configuration. In its excited state also, if you take it to excited state, it will be having all the 10 electrons present with it. All the 10 electrons present with it. Only these electrons will be shifted. And one electron shifted, one electron will be remaining here. Such type of, in ground state also it is completely filled. In excited state also it is completely filled. Whenever completely filled d orbitals are present in its ground state as well as in any oxidation state or excited state, all are such compounds doesn't considered as d block elements. And the example is zinc. And this question have been asked many a times in your board examination. Please do concentrate. Then, so that the reason why these are doesn't considered as d block elements, but they show certain other kind of properties which are similar to that of d block elements. The reason why it has been placed in d block elements. Understood? So please do copy this. We'll move to next.